Okay. Hi, everyone.
All right. And then Elliot, I will pass it off to you.
All right, I'm ready. Hi, everyone. I'm Elliot Keeker, and I'm a member of the Education Committee at SNCA. And so I will just be introducing what we're going to hear about today and our speakers, and then I'll facilitate some questions afterward. So we have two projects that we're going to hear from today on the topic of AI in archives. The first one is using AI for transcription and close reading of manuscript collections. We have two speakers from UNC Chapel Hill on that topic. Lydia Hendrick is a graduate assistant in technical services at Wilson Special Collections Library. She works on the Mellon-funded project on the books AI-assisted collections, and she's also an MSLS student in the School of Information and Library Science, UNC. Her career focuses in special collections and public libraries. And joining her is Nancy Kaiser, who is the Technical Services Archivist at Wilson Library, UNC Chapel Hill. She arranges and describes archival collections, and for the last several years has been working on reparative description to make finding aids for manuscript collections more accessible to family history researchers and genealogists. And she also works with Lydia Hendrick on that Mellon grant. And after they speak, we'll be hearing about a second project called Evaluating AI-Generated Image Descriptions for UNC Library's digital repositories. So joining us to talk about that is Desiree Stooks. She's the Software Quality Assurance Specialist at UNC Chapel Hill Library, where she develops and implements automated testing strategies for digital repositories and web applications. She also leads quality assurance efforts across multiple systems, ensuring usability, accuracy, and inclusive access to digital assets. In addition, her work focuses on accessibility compliance, including evaluating large language models for automated image description, alt text generation, using WCAG standards and established image description guidelines. And joining her is Ben Pinnell. He's the applications analyst at UNC Chapel Hill Library. He leads and contributes to the development of the special collections and institutional repositories for the library, as well as the preservation technologies that support them. In the last few years, he's also worked on the development of machine learning and LLM-based tools to support archival workflows. So we'll start with Lydia and Nancy, and then we'll move into our next presentation. And at the end, we'll have questions on chat or verbally. Okay, you guys ready? Go ahead and share your screen.
Everybody see that?
Yep, looks good.
Great. Okay. Hi, everyone. At UNC's Wilson Special Collections Library, and I'm sure at all of your repositories as well, researchers use manuscript collection. Oops, hold on a second. Just realized I'm not advancing. There we go. Sorry about that. Researchers use manuscript collections over and over again and in new unexpected ways. Materials brings new details to light all the time. I'm using this term close reading a little more loosely than perhaps scholars might. I'm not talking about meta-analysis of language structure and rhetorical patterns to uncover a deeper meaning and authorial intent. I'm really just talking about having to read every word on every page to find explicit and/or implicit evidence of an idea, an experience, or a person. My research and instruction colleague, Matt Turry, likens this kind of archival research to the proverbial search for a needle in the haystack. Close reading is inherently difficult work in 18th and 19th century archival collections. Firstly, practically everything is in cursive, and not all handwriters were equally skilled. And secondly, even the best, most descriptively analytical finding aids for these collections tend to describe at the aggregate level. Finding aids for 18th and 19th century collections typically are heavy on themes and overarching narratives, and can be quite a bit lighter when it comes to description of niche topics that are documented ever so briefly. And good luck finding that one item in a box full of folders full of 4-page handwritten letters. Recently, there was a researcher at Wilson Library who was studying breastfeeding in the 19th century. A keyword search of our finding aids would not point you to any collections. some creative conceptual and keyword searching with guidance from our expert colleagues in research and instruction, and a careful reading of our finding aids eventually got the researcher to a few collections that might prove fruitful. Once situated with the identified haystacks, if you will, the researcher had a lot more close reading to do to locate the needles, which they eventually did, thanks in part to the time and funding provided by a fellowship to do this kind of deep research. My remediation work over the last few years has given me the chance to do a lot of close reading, and most of it so far has centered records of enslavement, of which I'll say more in a minute. In the course of trying to shine light on enslaved people hidden in plain sight in a collection, I come across many other unusual and obscure topics, needles in the haystack, that could be highlighted as well. There's no end to what is interesting and what people will search for. I could spend a lot of time angsting about needles and haystacks that are going undescribed, but AI, I think, potentially relieves me of this worry. AI-generated transcription and AI-supported analysis of manuscript documents have the potential to greatly expand both the number of researchers who can do this kind of research based on close reading and the breadth and depth of their queries. I'm going to give a quick run through of some of the initial work Wilson Technical Services has done with AI in service of transcription for research that requires close reading. Lydia will go into greater detail about how we are going further with our experimentation with AI-generated transcription and AI-supported analysis of manuscript materials. If you're not familiar with From the Page, it's a platform that hosts crowdsourcing transcription projects. UNC has had projects up on From the Page since 2020, when the university library uploaded digitized images of materials from our collections in anticipation of needing work from home projects during the pandemic. After an initial burst of activity on the site, employee traffic slowed down a bit for a few years, but the general public tapped into it. In year-to-date 2026, we have had 192 unique users on the site. In fall 2024, UNC participated in a pilot project offered by From the Page to test out their use of Transcribus, a handwriting character recognition tool, combined with an AI overlay, which I believe was ChatGPT, to improve the quality of the transcription. Our test sample was records of enslavement from several of our slavery-era manuscript collections. We specifically chose records of enslavement because we have been working for the last several years on remediating description of the finding aids for these collections. UNC has more than 700 slavery-era collections, and the descriptive tools that researchers have used to access these collections for decades focused on scholarly researchers who studied the experiences of white people in the South and/or slavery, the institution. The overlooked the humanity of the enslaved people and were not helpful, if not harmful, to the genealogists and family historians who were researching enslaved ancestors. The scale of remediation needed for our slavery-era collection finding aids made records of enslavement a good test case to begin investigating how AI might be helpful to that process. Of course, we were also thinking more broadly about how transcription of any of our 18th and 19th century collections would be helpful to all of the close reading researchers, no matter how niche their topic, but we started with a known issue that needs to be addressed. So we tested out the Transcribus and ChatGPT model From the Page with a focus group of library science students who found it pretty useful, especially if they had minimal experience with cursive writing. We also tested it out with a group of genealogists who are descendants of the Hawkins and Haywood families, which were two of the collections represented in the pilot project. The genealogists hated it, mostly because the model was extremely careful not to make inferences about words unless it was 100% sure. Any uncertain words were replaced with an emoji, and this slowed down their transcription work and completely annoyed them. On the bright side, a few members of this group have stayed engaged with transcription at UNC, and we meet monthly for a transcribe-a-thon on Zoom. These folks are our genealogy brain trust. I regularly bring them updates and questions about AI and transcription, and they generously give feedback. From the Page has since moved on from Transcribus, embracing Gemini 3 back in December of 2025, when there was a quantum leap in accuracy of transcription. Lydia will have more to say about Gemini 3, but for now I just want to note that we have flipped the AI switch on a number of our collections that are already up on From the Page, and we are seeing that some of the community of users use it and some do not. It is on my list to reach out to all of the users and with some sort of introduction to the AI option to see if that nudges more people toward using it. Wilson's Genealogy Brain Trust is still skeptical of AI, but they have embraced it when it comes to ledgers. Previously, transcription of ledgers required some tedious coding for format, which no one wanted to do. But AI does that work for you now. Ledgers, I hope, are going to become much more accessible to researchers as a result of AI. In terms of records of enslavement, there are many enslaved people mentioned in account books of all kinds. And
We'll do it
AI
fast.
and I'm sorry, excuse me, and AI can certainly make it easier to find them without reading line by line, page by page. And Lydia will show you an example of this. Okay, in summer 2025, Wilson Technical Services was invited to participate in phase 3 of the Mellon grant on the books AI assisted. Our lane of the project is case study 2, legal volumes and handwritten documents. We have spent this first year surveying the AI and manuscripts landscape, learning about tools and experimenting with them, again, in the context of records of enslavement, because our scale of responsibility to improve access to them is so great. But we're confident that the skills we're learning now will be adaptable for close reading across other research topics. In year 2, we will be working with Antoine Hunter, an historian and professor here at UNC, on his current research project, with the goal of using AI to make identification of useful collections and close reading of manuscript materials more efficient. Professor Hunter studies the African-American experience in the 19th and 20th centuries, and in some ways he is looking for the eye of the needle in the haystack. He is looking for enslaved and free people who are in these archival collections, but our unremediated finding aid description generally fails to say exactly where to find them. And then on top of that, he is looking for documentation of very specific experiences of enslaved and free people. This is a tall order in archives that are hidden at best, silent at worst. Nevertheless, we're hopefully looking forward to finding out how the prompts and strategies we have learned in year 1 can be adapted and applied to Professor Hunter's research going forward. I'm going to turn it over to Lydia now to go into greater detail about the specifics of the tools she has been learning on, the evolution of her prompt writing, and show some examples.
Thank you, Nancy. Okay, so I'll talk a little bit about what year 1 of the Mellon project has looked like so far. You can go to the next slide. I think it has a little lag.
Yep.
Oh, there we go.
One more.
Back a little.
Okay.
Beautiful. Thank you, everybody, for being with us while we get through the technology. So being part of the Mellon project gives us access to LibreChat, which is a platform that brings together multiple AI models, many of the ones you've probably heard of, into one secure interface where you can experiment. It's very important to us that UNC's instance of LibreChat is a closed system. That means that the prompts and the files that we upload are not accessible to any of the model providers, and they cannot be integrated into their training sets. Because we're working with records of enslavement, we did not want to work in a space that would be scraped by LLMs for their own learning or for other commercial purposes without notice or consent. Next slide. Okay. And as Nancy mentioned, year 1 of the Mellon project is learning the tools. We wanted to compare the various AI models available to us to see if there was a major difference in the proficiency of transcription that would lead to an obvious tool of choice. In October of last year, I compared 4 different models that were available at the time, which were ChatGPT 5, Gemini 2.5, Claude Sonnet 4.5, and Llama 4. So the case study that we chose for this transcription project was the Manual Fetter account book which is part of our Southern Historical Collection here at Wilson Library at UNC. It's an account book that was owned by Emanuel Fetter, a professor of Greek at UNC Chapel Hill, that he kept from 1841 to 1844. It contains records of Fetter's personal expenses and has many entries that mention names of enslaved people and free people of color. The account book was already fully digitized and consists of 174 pages, so we thought it was a good size to start with. I first transcribed the first 10 pages by hand and then wrote a prompt that I used for each model, instructing it to transcribe the pages verbatim, and then analyzed and compared the transcription based on character error rate, word error rate, and number of hallucinations. So after comparing transcription from all 4 models, Gemini 2.5 was the best by far. And since then, the quality of the transcription has also improved as Gemini has released newer models in the past few months, as Nancy mentioned with From the Page using Gemini 3 recently. The latest version is Gemini 3.1. So to give you all an updated view, I'll show you a comparison between transcription from Gemini 3.1 and another new model, ChatGPT 5.5. So you can see the difference in transcription quality is still very apparent today. So this is a transcription that I ran last week. So these are very recent results. On the left is a page from the Emanuel Fetter account book. On the right is the transcription from Gemini 3.1 Pro. The errors are highlighted in red. Out of 779 characters, Gemini 3.1 Pro had a total of 3 errors. It missed an O in the town name of Pittsboro, mistranscribed the number 6 as a $, and the number 5 as a 3. So it's not 100% correct, and ideally, it's always best to have a human review it, but it's doing pretty good. It even picked up the marginalia in the bottom left-hand corner that's written sideways, and it transcribed that number correctly. So now we'll compare this with transcription from ChatGPT 5.5 that I also ran last week using the same image and the same prompt. So immediately there's a lot more red. Out of 779 characters, it had a total of 104 errors. It got a lot of the numbers wrong, but more importantly, it got a lot of the names wrong. It mistranscribed Sylvester as oysters, Mahala as machine, and it completely left out the name John in the first line. ChatGPT also recognized that there was marginalia in the bottom corner, but it transcribed it completely wrong. So the model that you use does make a difference, and it's something to take into consideration if you're interested in AI transcription. And a few prompt writing tips that I learned from this experiment. Prompt writing is a very iterative process where you often need to go back and change your prompt based on your results. So it's best to keep a document where you can record your prompts in the different iterations that you use so you know what works best. For transcription, I found that providing context within the prompt for the document you're transcribing has been very effective. Context like the type of document, whether it is an account book, ledger, or correspondence, including the time and the period and location it was written in, can help the AI know what vocabulary it should be expecting. And you should also provide clear instructions on the format of the transcription that you're looking for. Do you want it in a table format? If so, how many columns? What should each column include? And I also found that I had to explicitly write in the prompt that all marginalia should be included under the table. Otherwise, it would add it to the closest row or just exclude it entirely. Once we decided to use Gemini as our primary tool and finalized our prompt, we started to think about how to scale up our transcription. LibreChat only allows you to upload 5 images at a time, and Emanuel Fetter account book was 87 images in total with 2 pages per image. Instead of running the prompt 18 separate times, we worked together with a programmer on the Mellon team, Anamika Lal, who created an API that automatically ran the prompt over the different sections and then put it all into one searchable PDF that we hope to eventually put into our digital repository and connect it with a finding aid for researchers to access. So now that we had the transcription all in one file, we were interested in whether we could write a prompt to have AI scan the entire account book transcription and identify names of people within the text. We were especially interested in whether it could reliably identify names of people who were possibly enslaved or a free person of color. As with many historical documents that are not legal documents, it can be difficult for even a human to identify who a person is and what their legal status might have been. It's often done by piecing together clues and going by conventional patterns used at the time. AI is able to analyze the text and pull out the names and information, but I found that it requires human thought within the prompt to ensure that it preserves the nuance and the complicated nature of the historical materials. Part of my process when writing the prompts for this close reading was to make sure that some of the uncertainty was preserved so that we're being faithful to the original material and also encouraging future researchers or students who may use these resources to think critically about the primary sources and how to engage with them. So I have a few examples from the dataset we created from the manual-funded transcription to give you an idea of how we tried to achieve this and what the results were. So to keep any uncertainty that is originally in the manuscript, I prompted the AI to create a column for possible statuses to account for entries where there may not be enough information to confidently choose a singular status. I also created another column where I asked the AI to include its reasoning for why it chose those statuses. What criteria was it looking for? In this example, which is from the same page that we looked at earlier during the transcription example, it identified John as possibly an enslaved person or free person of color by the description of boy as a diminutive term that was often used by white enslavers during that time period. I also thought it was important to show the original context that the name is found in. So the last column is for entry description, which includes the original wording of the entry. The second example, the AI identified a mother and son connection from two different entries and used the known status of the son, Stephen, as an enslaved person to help identify and inform the status of the mother, Beck. This was something that it did without me explicitly instructing it to do so in the prompt. AI is generally good at language and pattern recognition, so this was an interesting way that it manifested in the dataset. And finally, this example is one that is a little more ambiguous. The first row is for an entry where the original wording is by Mother Goose's melodies for Fred. The AI identified Fred as a possible enslaved or free person of color since he is identified by only a first name. However, it reasons that since he's receiving a children's book, he could also potentially be a white relative. It once again draws a connection with people mentioned later in later entries, where Fred is mentioned alongside Dicey, who is explicitly described with a racial signifier. Using this additional context, the AI reasons that his association in the entry with Dicey as an enslaved person may also suggest that Fred is an enslaved person or free person of color. I found it interesting that the AI is capable of this kind of reasoning and that it includes it without having to be instructed to do so. And these kinds of data sets could potentially be added to finding aids to help future researchers identify possible areas of interest or for genealogists who are looking for a particular family member or ancestor. In addition to our work with close readings of transcriptions, we have also been experimenting with creating data sets of names directly from finding aids. For many of our collections that have undergone remediated description, our archivists have added in-depth scope and contents notes that include all instances where enslaved people and free people of color are mentioned, which have historically been overlooked or excluded from the description. One of these remediated collections is the Neal family papers. Because of the added detail in the scope and contents notes, we've been able to write a prompt that pulls out that information and creates a dataset that's similar to the one we just looked at from the Manual-funded account book. Pulling from the finding aid allows us to cover a wider range of materials spanning the entire collection, including correspondence and financial materials, bypassing that transcription step. The dataset includes the names of enslaved people and free people of color found within the collection, as well as location changes, related individuals, and additional context that might be helpful for researchers and genealogists. And we're coming to the idea that if remediation of description is about improving accessibility, we need to think about ways to get this information into other spaces that may be more accessible for genealogists, such as enslave.org, which is a website that hosts searchable datasets of enslaved people who appear in archival records at a variety of institutions. The site has its own controlled vocabulary, so I'm currently working on prompts to create a dataset that uses this controlled vocabulary that's not always in the wording of the finding aid itself. So that's one of our ongoing projects at the moment. And now I'll pass it back over to Nancy for a look into some of our other future projects. Thank you.
Hold on a second now. Not sure why the slide won't advance exactly when I want it, but I'll start anyway and we'll see if it catches up to me. Maybe Lydia will play with it. Okay, as I mentioned earlier, Antoine Hunter will join the Mellon Project next month, and we'll find out more about his research goals and interests and how we will use AI to facilitate that work. Before then, we're going to do a quick dive into AI-generated summaries and subject tagging. We're not sure he will need this, and we're not sure how we feel about it for remediation and future description work, but we're going to take a look with a critical eye for how well it addresses needles and haystacks. We will probably start by asking AI to summarize and subject tag individual documents and then see what it does with an entire folder. Some of these outcomes are outside of our control, so I'm not committing to any of these things. I'm just saying that these are things we're working towards. First, we want to honor the work of our community of transcribers over at From the Page by getting transcriptions into our digital repository at the item level so that they are searchable and repurposable by researchers. Our colleagues Anna Goslin and Seja Wilson, who work on the digital repository, are deeply engaged right now with the migration of our digital collections from Contentium over to our new repository. But they've been very helpful partners in conversation right now. So we're looking forward to working with them in the future on moving the transcription over. We also want to figure out how we're going to communicate to researchers that some or all of the transcriptions may have been created by AI and that they have not necessarily been reviewed by a human. Lydia's work with transcriptions has a lot of human oversight, but that isn't sustainable across the volume of transcription that is happening over it From the Page. We want to use AI to closely read more of our remediated finding aids for slavery era collections in order to create more data sets for enslaved.org. And then Wilson Technical Services has a few other things in the works outside of these projects, remediation projects, including a pilot project that was led by my colleague Patrick Cullum and a team of graduate students to digitize, transcribe, and create a spreadsheet with information from portrait sitting cards from the Bear Wooten collection. After these initial projects, we're not sure yet where we will go with AI. There are a lot of questions around environmental impact, and I think we will want to be thoughtful about where and when to deploy AI. If we want to be good stewards in the library context, we need to think carefully about necessary versus interesting versus whimsical applications of AI and be judicious in our use. In terms of archival description for 18th and 19th century collections, does it make sense for us to do a lot of AI-aided descriptive work up front, or do we teach researchers to use AI for their own transcription and analysis that facilitates their close reading research? And what about 21st century collections? Maybe it's a different calculus if we are wanting to improve description of born digital materials. Speaking only for myself, I think using AI up front to facilitate better access to our slavery era collections is a solid case for necessary use of AI, because I think we already owe it to researchers to remediate our past description. Beyond that, maybe it's case by case, asking what problem we will be solving. The main thing is to keep an eye on the innovations, maintain a healthy degree of skepticism, but don't categorically reject it. Thank you so much for joining Lydia and me for this presentation, and we look forward to being in conversation with you.
Thanks, Nancy and Lydia. And Desiree and Ben, whenever you're ready, you can share your screen. Looks good.
Okay. Still looks good. Everybody can hear me? Okay.
Yep.
All right. Good afternoon, everyone, and thank you for being here. My name is Desiree Stukes, and I'm a software quality assurance specialist. And joining me is software developer Ben Pinnell. This presentation focuses on our collaborative work evaluating AI-generated image descriptions for UNC's digital repositories. My role centered on the evaluation process, and Ben's primary focus was on the technical implementation. With updated Title II ADA regulations from the DOJ, institutions are under pressure to make massive digital collections more accessible. At UNC libraries, our repositories contain roughly 2.5 million images. Creating quality descriptions manually at that scale is time-consuming with limited staffing and existing backlogs. During the pandemic, UNC started several work-from-home projects for our staff and student workers to address digital accessibility, including creating descriptions for images. Work was initially completed in an Excel spreadsheet and then migrated to a customized solution from the crowdsourcing organization from the page. AI now offers a viable and scalable option. Alternative text, or alt text, is a short textual description of an image that is read aloud by screen readers for users who are blind or have low vision. UNC will also provide longer descriptions, including transcriptions for more complex images. Good alt text should be accurate, contextual, and concise. We built strict word and character limits directly into the prompt to encourage concise, screen reader-friendly descriptions that varies based on image complexity. For this project, our evaluation framework was informed by WCAG accessibility standards, the Cooper-Hewitt guidelines for image description, and UNC's conscious editing guidelines. We compared multiple AI models to evaluate the quality of image descriptions to determine strengths, weaknesses, and risk. We also considered the cost to implement for millions of images. Another goal was to determine what level of human review would be required and how to integrate AI into existing workflows. These research questions guided our work and went beyond just asking whether AI could generate alt text descriptions. First, we determined if AI accurately reflected what was present in the image, including any actions, interactions, or activities taking place. We also evaluated whether AI understood context beyond object recognition, whether AI introduced biases, assumptions, or hallucinations when describing images that could be considered harmful or sensitive. Descriptions also had to meet WCAG accessibility standards. And finally, we asked what level of human review is realistic at this scale. We initially selected 88 images, which included photographs, documents, maps, political cartoons, and famous people. Images representing various identities, such as indigenous, race or ethnicity, and gender, were also added. Ben refined the prompts through multiple testing cycles. Each set of outputs we evaluated using a structured 5-scale Likert rubric and our guiding documents. Results were compared across models to identify patterns. Ben developed and refined the AI prompts on what to include, what to avoid, and how to handle uncertainty. The prompt instructed the AI to describe people, objects, activities, documents, and spatial relationships. If the AI felt confident of the age, gender, race, or ethnicity of the people pictured, then include. Otherwise, do not include if there's uncertainty. The AI was instructed not to make unsupported assumptions and not to provide a count of individuals when there were a group of people. While metadata such as title, format, or geography were provided about the image, the AI was instructed not to simply repeat that information, but only include it in the description unless visible and if it aided with understanding context. This slide highlights some of the key criteria we use throughout the evaluation process. With cursive signatures, for example, different models produce different transcriptions. We also evaluated how well the systems described actions and interactions, since several models occasionally hallucinated activities or objects that were not actually visible. We tested verso images to see if the models would recognize that it was the back of another image, and included an image that was upside down. Our top ranked models did well with the upside down image, but some produced hilarious results, such as indicating that people were hanging from the ceiling. Another major area was identity description, including race, ethnicity, gender, and age. To evaluate outputs consistently across all models, a 5-point Likert style rubric was developed, focusing on both accessibility and image description quality. The rubric evaluated both technical accuracy and accessibility value for screen reader users. Because of time constraints, I only highlight a few examples of both successful and problematic descriptions to illustrate how the different models performed. There are additional examples available at the end of the slide deck for your later review, and we'll be sending that slide deck. The models were good at spatial positionality and architectural detail. Image 1 is described as a black and white pen and ink illustration on paper showing a tall wooden waterfront building beside lower sheds, a pier, and choppy water against a retaining wall. Image 2 is described as a black and white landscape photograph taken from inside a shaded stone and vine-covered archway looking out onto a curving dirt road across grassy slopes. The models were also good at transcription or providing synopsis of textual material. However, as I mentioned before, one area where they differed was cursive signatures. Most models were strong in identifying famous individuals, landmarks, and historical context. The AI models were able to recognize well-known figures such as Pauli Murray, Zora Neale Hurston, Michael Jordan, or Coach Dean Smith. Claude often provided stronger historical context. For example, Zora Neale Hurston was identified as an author and anthropologist. For ChatGPT, we are using an Azure implementation which blurs faces for privacy and commercial reasons, causing famous individuals not to be identified in the description. There is an additional paid service for this facial identification, so therefore UNC is not focusing on facial recognition in this initial phase. We had hoped we could pay to lift the limitation, but unfortunately it's not that simple. This example illustrates several challenges in one image. Counting, sorry for the dogs in the background. Counting, hallucinations, identity interpretation, and action recognition. Some models fail to identify all of the individuals present in the scene, particularly the smaller or partially obscured figure in the red rectangle. Most models counted only 3 figures instead of 4. In addition, that obscured figure was incorrectly identified by some models as European or white rather than indigenous. Other models incorrectly interpreted the action occurring, which is designated by the red arrow. It misrepresented the preparation of a gallows for the indigenous individual seated on the ground, even with the caption, Introduction to the Indian Gallows. The man performing the action was described as climbing, using an axe, or standing on a branch. There has been an improvement with newer models in our latest testing cycles, where they went beyond a vague, generic description and provided a more accurate interpretation of the racial dynamics, roles, and action occurring within the scene. This slide displays the overall rating and some of the strengths and weaknesses of the top models. Overall, Claude consistently performed the strongest in contextual understanding and descriptive quality, while Gemini models excelled in spatial detail and the use of respectful identity language, but struggled with missing outputs in some cases. These missing outputs were resolved with prompt refinement. The ChatGPT models improved across rounds, particularly with contextual sensitivity and illegible text handling, though they were sometimes less consistent with identity description and famous figures. While AI should support archival accessibility work, it should not replace librarians or archivists. The central question becomes, what level of accuracy is acceptable? Our findings suggest that AI can be very effective for generating descriptions, but human review remains crucial. One major issue involves how models handle racial slurs and harmful language. Our proposed approach is to summarize slurs in alt text while preserving the original language elsewhere in transcripts and metadata for research integrity. We also discussed transparency for patrons. AI-generated descriptions would be labeled in the metadata, but not announced within the alt text HTML code to avoid unnecessary redundancy for screen reader users. Overall, we envision a human-in-the-loop workflow where librarians provide the ethical oversight. I'll now turn it over to Ben.
Hi, I'm Ben Pennell, and I'm going to be talking about the implementation and integration of this workflow into our systems. So as Desiree was just talking about, we ended up with sort of three top models when looking at Claude, Gemini, and ChatGTP, and ultimately went with ChatGTP for our initial pilot. And one of the primary reasons for this is that our campus has an existing relationship with Microsoft Azure, and we were able to get reduced funding that way, covered the funding that way, and the results were comparable. Processing times and costs were all good. The main issue is what Desiree already mentioned, which is the facial blurring, which affects the ability to recognize famous people or include demographic information. Next slide. So in terms of how we went about implementing this, the workflow is currently a fast API microservice, which is just dedicated to doing this work. And we're using an abstraction called Light LLM so that we can switch out which models are being used. And the overall workflow is split into two steps at this point. The first of which is the description pass, which generates per image a full description, which is generally several paragraphs, the alt text, a transcript of any text in the image, a safety assessment form, which I'll talk about more in a moment, and we pass context from our repository in order to help it understand what it's looking at. This is primarily pulled from the mods records that we have when they're available, but also some hierarchical information such as folder names and collections. The second pass is the review step, which is an attempt to verify the model's outputs from the first step to check for inconsistencies or unsupported claims or biases in the actual output from the LLM, not the actual content having biases, but the model itself saying something that appears to be biased. And lastly, we have something that we are calling safety scores, where we calculate how likely an image is to need review by a human based off of the various factors that we identify about an image. So in terms of review, since this is such an essential step to ensuring the safety and accuracy, we've been implementing a staff review interface so that we can view the images that are being described along with all of the outputs and safety information and review information about them in one place. And an essential part of this is the safety assessment form that I mentioned in the previous slide, which calls out factors about the contents of the images that might prove difficult for the models to give an accurate description. This could be things like whether there are people in the image, if the model attempted to describe the demographics about them, or if there's text and how clear the text is or how clear the image is, all things that make it potentially harder for the model, as well as some things which are more like safety warnings, such as if there's nudity or violence in the image. And then the review interface allows for keyword searching of all these outputs, as well as filtering on the safety and review tags and sorting by risk scores. So this is just a screenshot of the current state of the review interface for one image. So we can see here that it's displaying the full description, and we have the option to edit it in place, and there's no text in this one, so the transcript is blank. And all of the fairly lengthy safety assessment fields are displayed there. But to make them more usable, at the top of the screen, there's the search, and on the left is the filtering, which can be expanded to see all the positive identifications in the safety and review forms. So at the moment, we are primarily focused on integrating this with our digital collections repository. And the first pass of that was embedding alt text into the public user interface from this workflow, which works by simply adding alt text tags into the markup of the page. But we're also indexing the full description and transcript information, not visible to users, but therefore searchability, to improve the ability to find these images based on content, since the actual descriptive metadata is often sparse for this large data set. One important aspect here is that we store staff-provided transcripts and full descriptions or modifications separately from the outputs from the models to ensure that the staff provided versions of them take priority and won't get overwritten by future runs of the LLM. And we do plan to display the transcripts in our IIIF viewer once the transcripts are in a better state, and also we're looking at integrating them into some access copy PDFs for making searchable PDFs of images. So while we've been working on this, we've tried to be aware of the environmental impacts, as well as trying to keep the workflow as efficient as possible. So this is just a listing of some of the approaches that we've taken to try to take that into account. And I won't go into too much detail on them, but the first one, token compression, is shortening the values of the safety and review forms into basically codes, which we expand back out to make human readable. And this cuts down on the amount of output the model has to do and the amount of work it's doing. We've also done a lot of passes at revising our prompts in order to shorten them and cut down on redundant instructions, which actually significantly reduced the number of input tokens. We also originally had a 3-step workflow where the alt text was generated as a summarization of the full description and the transcript. But we eventually found that with newer models, it can handle all those tasks in the initial prompt. And so we merged that into the description prompt, which cut down on the amount of time taken by the workflow significantly and the number of tokens and used by a decent amount. We also, as Desiree alluded to earlier, have set hard limits on how long the responses can be and tried to ensure that the model takes a more concise approach to writing out descriptions. We're excluding fields that are not applicable to an image, such as if there's no people, we don't have to report on if there's demographics. And lastly, using the risk scores that we mentioned earlier, if a image has a very low risk score, we are skipping the review skit step in order to cut down on the excessive work being done by reviewing something that does not really have any problematic content. So in terms of next steps, so far we've been working with a sample set at has expanded from the initial around 90 images to about 130 as we pulled in additional test cases. But in order to get a better sense of how this performs over the whole repository, we are looking at expanding to somewhere between 500 and 1,000 images for the test set. We've also been continuously iterating on prompt refinements in order to fix minor issues that have come up and improve the feedback to users about what types of things they should review. And as part of that, we've been refining the review interface. We're also looking at adding potentially an additional transcription pass, since as the last presentation indicated, ChatGPT is not very good at transcribing text, particularly cursive handwriting. And newer versions of Gemini are very good at it by comparison. So since we're already identifying the type of text and image and how difficult it is to transcribe, we can potentially use that information to conditionally trigger transcription with a different model. So we'd be expanding this out to the whole image set, and once that's farther along, we'd be looking at also using this in our institutional repository rather than just the digital collections repository. But on top of that, we just have to keep up with newer models and reviewing to make sure that there aren't any regressions or new problems coming from the most recent updates. So in conclusion, this workflow in AI seems to be promising, but it's still imperfect. Human expertise is essential here to ensure the safety and accuracy of the content and to make sure we're not introducing harmful descriptions into our repository. But the AI is producing pretty good output at this point, and it can help us to address the rather large backlog that we have to meet DOJ deadlines. And in doing this, we just have to figure out the right balance between providing accessibility improvements, having sufficient accuracy, balanced against the ethics of this process and the environmental impacts of the workflow. And this last slide is just some resources that people can look at after the fact, such as the Git repository and all the guidelines that we've been following. Thank you.
Thanks, y'all. Thank you so much. And we have a little bit of time for questions. You can chat or raise your hand. And I had one I'll start us with. You all are talking about using these at UNC Chapel Hill, but I wondered if you thought some of the prompts that you're practicing and things that you're doing could actually be written up as guidance for other repositories to use similar processes on their collections.
So on the resources slide, we have links to the GitHub repository, which contains the prompts as well as the processing stuff that Ben has been working on. So,
and while we haven't
go ahead,
advertised it to like other institutions to use, I don't think there's anything especially UNC specific about the prompts. There might be some stuff that's sort of specific to our collections to some extent in terms of what types of issues we have to deal with, since we sort of have to iterate on addressing issues that come up in some of the archival images that we have. But yeah, I think this is definitely information that people could use elsewhere.
That's helpful. Thank you. Any questions from our audience? Looks like Rachel chatted. Do you have guidelines or tools for the human review process of the output? Was that for a specific group, Rachel, or for both? For both.
Well, I'll just say right now, we're working on the interface for the human review, how that workflow is going to work. We really haven't drafted that up yet, but that is something that we will be working on. So. We've been talking about, what the risk score is going to be in order to trigger a human review.
In terms
And
of,
I'd say,
yeah,
there you go. I'd say for our project, the human review is mainly done by me at the moment. But I'm putting together a prompt library document that I hope to use as a LibGuide eventually, to kind of help people go through the process of comparing transcription by like character error rate, word error rate, that kind of thing. So in the works.
yeah, I think we're still working out what the actual guidelines and who is going to be responsible for these steps. I think the impression is that the people that are depositing and are the most familiar with it would be the ones responsible for doing the review. But that's still to be decided at this point. And the tools we're using are fairly custom, so I don't know if I can say that it would be like shareable or common to other people.
Thanks, y'all. We only have a few minutes left, so we probably don't have any more time for questions, but I'm sure you guys would welcome emails if people wanted to ask you about these projects. And the recording of this, Kristen will be posting. What's that location, Kristen, of where you'll be putting this?
Good question. So this will be, this along with the March and February Lunch and Learns that we did, will be on the SNCA website. And there is a tab at the top, I'm pulling it up as I say, a tab at the top that says resources, and it likely will be put underneath that tab. But once those go live on there, I will send out a message to the listserv with the links to the different webinars, including this one, as well as any slides that we have to share as well.
Good. Thank you. Well, thank you everyone for coming, and thank you so much to our presenters. I really appreciated the ethics focus specifically of these as well. Yeah. See ya.
Bye-bye.